Thank you very much. Thank you, Yossi, for the invitation. Also, thanks to NSTF for hosting this event. It's a great pleasure for me to talk to you on this opportunity. When Yossi communicated with me, indicating a topic of solutions to combat load shedding, my immediate response in my mind as an ordinary citizen is go solar. So it's my title of my talk today. So go solar, period. No suspicions, no explanation. So no emotions. I just want to bring some facts and hard figures based on my own stories and measurement. So maybe it's a good idea that I stop the video so that I can save a little bit of bandwidth. So let me move my cursor. So let me start with my colleague at the University of Pretoria, Professor Ian Craig. So his home system, as he called the load shedding Moses. So initially I thought that this term has a particular religious connotation, but actually it does not. So its origin, according to him, is a Malay word, means the opponent or superior. So he needs about 1,000 kilowatt hour per month for his house. And he installed in March 2015, a 3 kilowatt solar PV system with a battery pack. The cost of it for him at that time was 200,000, which was about 4% of the house value at that time. So the system generates about 15 kilowatt hours per day, and that's about half of his total daily consumption. As you can see from the top right picture, he used the lead acid batteries, quite bulky, but to save the cost. From low right picture, you could see that the batteries were happily supplying the house during the night and when Eskom was load shedding. So last week, we asked for his permission to use his pictures in this presentation. He told me that this is probably the most valuable investment he has ever made in the past few years. So by the way, from the top left picture, so you could also see that Professor Craig is also a solar thermal fan. So my own story of going solar started with a battery pack backup system, which I installed during the week before the hard level 5 lockdown in March last year as a savior for working from home during the lockdown and during load shedding, because I knew with much certainty and dismay that I would be working home for the coming years and Eskom would carry on disappointing us. So my battery backup system was famously branded. I call it the A-rated system. From a 702 radio interview, I heard that Mr. Narrator had exactly the same system as his house in Pretoria East, which I also live. So I needed to plan for the worst scenario that could happen to me. Possibly at that time, we all know stage 8. So at stage 8, so Eskom is going to load shed us for about 4.5 hours. So only leaving 3.5 hours in between. So this is what is at disposal for me. So then I have to, based on my engineering judgment. So I sized my battery system to carry 5 kilowatt hour of energy. I need a 5 kilowatt inverter to charge the battery in about 2 hours. So hopefully to discharge it for 5 hours. So the system at that time cost me about 100K. So my next door neighbor, Mr. Markle, also installed a similar type of battery backup systems at around the same time, but at a much larger one. So then on the 20th July 2021, which is basically 3 months ago, so there came the University East Crusade, what I called, the Wapasrand substation code 5. So a large part of Pretoria Mid-East was affected, I guess, inclusive of Mr. Andrew Derrita's home. No definite reason, of course, was given. Could be diluting or vandalism from the preceding grid that spilled over from KwaZulu-Natal to Gauteng, or more reasonably, was it because of lack of maintenance? Like the Crusade, this is a multiple happening event. In July 2018, the same substation was burned down and the Pretoria East was without power for 2 weeks. It was an extremely embarrassment for me because it happened during the state visit of Chinese President Xi Jinping to South Africa. And I had to wash myself clean and dress up to meet him and see him. So this time, in July 2021, it took 8 days to get the power back with a temporary measure. As the DA Councillor, Mr. Philip Nell, informed the residents, the insurance was sorted out after 3 years and the tender was about to be issued, and the full restoration of the substation is going to take another 18 months if it starts timely. As my neighbor, Mr. Marcus, complained, he said he got the battery backup system to love the ANC, but now he has to get the PV system to love the DA. So now it comes to the rise of the great Genghis Khan. I could bear no more either, because I decided to go for a full PV system at that time. So I know the name of Genghis Khan leads to mixed reactions in both the Eastern and Western cultures. But I'm promoting a PV system, which might not be to the ESCON or somebody else's liking. But as I said, I just want to focus only on the facts and figures that I know. So immediately after the darkness and coldness, I decided to upgrade my battery backup system to an off-grid PV system. So I did some optimization again. I decided to go for 10 solar panels, each of 35 watt peak, which makes a little bit of over 5 kilowatt peak in total generating capacity. So then I decided to get the second inverter of 5 kilowatt to make 10 kilowatt in total, and 2 additional lithium-ion batteries to make it 10 kilowatt hour in total. So in such a way, I can hook in the stoves, water heaters, geysers, and the solar system that I have in my house. So with the maximum peak power tracking controller, so I could essentially go completely off-grid. So this is how it was operating on the 11th of October when I got invited from Yangtze. So I took some pictures from my system. So I can read the real-time monitor and the solar power generation, the load profile, the kilowatt hour consumption profile, the battery status charge, and with some kind of uncertainty band, the power flow, the power quality, the weather conditions, etc. So as you can see that during 11 in the morning or to 12, my load was at about 1.86 kilowatt, and the PV was generating 3.98. I don't know whether it's too small to read, but I can read it for you. So it's a 3.98 kilowatt. The battery was on average at 87% full. But now later during 12 o'clock or 1 o'clock in the afternoon, so when my load was 1.34 kilowatt hour, the PV was 1.41, and the battery was completely full, 100% full. So the PV was not at its full generating capacity because it was tracking my maximum usage. The city of Botswana does not allow people to inject the surplus PV power back into the grid. Otherwise, I could have controlled my PV to do that. So the picture at the right is the power flow at around 7 p.m., where there's no more sun, and the battery was supplying the full load. So there's a small amount of the electricity going back into the grid, which I left it on purpose for more flexibility and for like illustration purpose, that I could, in fact, output the back into the grid if we get the benefit of it. So it is operating like this almost every sunny day. So these are the pictures for 4 consecutive days. So in South Africa, we are really blessed with beautiful sunny days. So I can take note of the following. So on sunny days, I have a relatively stable PV, very reliable PV production. I got between 20 to 25 kilowatt hour per day. So average at about 22 kilowatt hour. Secondly, I use about 95% of PV generations. So I still use about 13% of grid power. So this is because I did not cut the grid connection completely. I could, of course, if I would. My system would be completely grid independent. So the other observation that I can make are that my PV system was not generating at the full capacity. So during afternoon, my usage of electricity is very small. So and the battery is full. So it should have easily generate more. Actually, I can calculate it, roughly estimate to be about 30% more. So this scenario, or we can call it a waste, does not only apply to me, because it also applies to my neighbor, as I communicate to him, and also almost all other households that we helped with PV systems. We do help a lot of people to install the similar kind of PV systems. So if you want to satisfy your peak power, so you have to have a little bit of over design. So you can have a local optimization, but globally it might not be optimal. So if we can pool together, then we can get more PV output collectively. So this is exactly the idea behind what I'm going to propose. So this is the balance sheet of based on the hard figures. So my total cost, including the battery backup system, is 200K. So I doubled the cost, exactly the same as Professor Craig, like 6 years ago. I used my company sort of just to claim back the trial B tax incentive. So I don't know whether the audience knows there is a trial B tax incentive. If you install solar type of product, you can actually claim that cost with a depreciation of 100% in the first year of your company income. So so the actual cost for me is actually 144K. So, but I got a very big, a slightly bigger system at 5 kilowatts at the DC side and 10 kilowatts at the AC side. So I save, say, average 22 kilowatt hour per day. So my average electricity price is 2 rand. So I knew that I'm going to pay more, say 2.5 for the consumptions, about 500 kilowatt hour per month. Because I knew that because we helped the city of Zwane for the cost of electricity study for the next year, so which was submitted for NERSA for approval. So my daily cost saving is around 44 rand per day. So these translates to about 16,000 per year. So my simple payback is about 8.97 or 9 years. We all know that the electricity price is going up, particularly more than 10% in the next 2 years. So my real payback would much shorter. Say I would guess 6 years. So even if I decide to sell my house within 6 years, I assume that I assured my wife that we're going to get the money back from the new market price of the house. So in Pretoria East, it's actually become quite a common practice to install solar panels to new complexes, and house prices are actually going up because of this. So also, as I noted before, my PV system could potentially generate 30% more. So if I take these into consideration, that is to assume that we have a way to harvest this additional 30%, then my payback period is 6.9 years. So my talk is all about the possibilities to get this additional 30%, which I will explain in the next few slides. But for the moment, that just simply scaled it up to the size of Medupi, because we all know what's happening in Medupi, just for interest's sake. So we know that on the 2nd of August, 2021, finally, after 14 long years, so Mandy Wiener and the ESCOM spokesperson brought us the announcement and the good news that Medupi project had finally completed for a total cost of 135 billion. let me just scale it up. So I use my figures, just multiply to the size of Medupi. So Medupi's total capacity is 4,764 megawatts. So then the total cost of PV system matching that size will be around 137 billion. Is it really more expensive? Yes, mathematically by 2 billion. That's a lot of money. But remember, we have a explosion at the unit 4 of Medupi, and the experts estimated that we need another 40 billion to fix it. So if we add these 40 billion to that 135, so we get 175, which is much more bigger than 137. So coming back to my system, I could identify a couple of immediate issues. Firstly, it's still a lot of money for people to take up the PV system. So especially this money is completely out of the pocket. So the current average house value is around 1.4 million for the country. So a PV system could be currently at about 10 to 15% of the average house price. So this is not affordable. So I would assume that ideally many people would consider it affordable, say if it is 2 to 5% of the house value. And then there are a lot of more options to fund these smaller percentages, such as to take, say, from Standard Bank, you've got the access bonds from an existing home loan or other source of funding. Secondly, from an investment point of view, the payback period for capital investment, so 7 to 9 years, is still a bit too long. So ideally, a good investment, so you can look at the payback period of 3 to 5 years. So this might arouse a lot of business interest if the payback period can be shortened. So my further slides are some of our very rough thoughts to address these two issues. So our thoughts are that we need the household and investors to collaborate together, so then we can combat load shedding on scale and relatively quickly. So our first message is to get your home ready for solar. So get it ready to get the certificate for affordability. So how do we work out that one? So our first suggestion is to get the home ready for solar is to have the battery ready DC supply. So this will consist of battery housing and interface to supply DC load only, with a smaller discharge control, with a smart discharge control. And this is applicable to homes with low grid access or very limited access, yet to satisfy the essential demands of lights, fridge, TV, cell phone, charging. So this option carries a very, very low installation cost, as indicated by the table at the bottom of the page, which we actually got it from one supplier. So it's actually a real cost. So benchmarks against the average cost of a South African 3-bedroom house, the DC home supply upgrades or a completely new installation cost is around 1.1% of the house value. So another option is the battery AC supply system. The key features are the battery housing and the interface to supply the AC load, smart charging control, easy integration for existing power network. In addition to nice fridge, TV, cell phone charging, you can also power certain AC loads such as stove or motor-driven systems. And AC hose supply updates or a new installation is about 3% of the average South African 3-bedroom home. So our second message, I write it as number 3, but our second message is to pool the solar together. So we believe that this is a good step to have a license to profit. So this concept is to have a third party or an independent party to invest in the smart charging infrastructure and a new type of power supply and a delivery business model. So the key infrastructure includes green power generation batteries such as lithium-ion batteries, online management platform, grid tied or not, charging station with charging modes, battery status and health monitoring, battery distribution, and or delivery fleet. The infrastructure could be distributed at the residence or centrally at the place close to the community. So technically, we need the charging design to ensure power quality, so real-time monitoring, sufficient interface, and smart switchings between different sources. So in terms of operation, so we are looking at key operational features such as green power charged batteries, which are ordered, used, and returned, and a low electricity price, then the grid tariff, battery health report at the charging station, electrified delivery trucks in support of electrification, combat load shedding, and emergency power supply. So in our opinion, such an idea offers a high level of suitability in a quick solution to load shedding for the wealthy and affordable, in addition to its obvious contributions to rural electrification. So it offers much improved green power integration even for urban areas, as it offers many general benefits such as reduced grid pressure of ongoing load growth, and the economy recovers, and the emerging introduction of electrical vehicles, because we know that that is also coming, as well as flexible energy trading models to slow down electricity price hikes. So the basic idea of our recommendation is a shared partnership and a shared participation from households and the third-party investors. So there are three parts in terms of PV cost: those on solar panels, on the power electronics, and the batteries. If you look at the individual homes, such as Professor Craig's, my neighbor, and myself, so each of us is paying for these three parts. So the recommended model would require that the household are contributing half of the power electronics. So when I say the household, it might be a third party as well. Say the municipality can play a role here. And the third party can pool the solar together and is contributing the rest. Yet it could make use the additional 30% of the waste that each of the household is currently doing. So in terms of green power integration, so the urban areas are able to expand the solar panels with biomass, such as the municipality waste, while in rural areas to include wind, biomass, and biogas, etc. So there are additional general benefits as well. It reduces the long technical loss due to solar panel theft or fire. It reduces the operational cost from the low levelized cost of energy due to large scale or pooled together installations than single solar homes. And from the reducing the billing and peak demand charged from the grid, it also reduces the emission from the high level of self-consumption of renewable energies. So these are, of course, only thought to be tested, especially on the feasibility at the operational level and the feasibility of the business at the larger scale. So at the university, so we test our ideas by working with others. Actually, the idea that I'm talking about, so we do partner with a particular mine at the moment, so I don't want to name the name for so long. So we do have an implementation plan consisting of 3 phases. Phase 1, pilot. Phase 2, operational. Phase 3, rolling out project. So the scope of the pilot project is to test the technical side of the idea. So we decide to say choose 10 rural homes. Each consumes roughly 2 to 3 kilowatt hours during the night. So I should correct this one, assuming that some of them are not even electrified, but we need to select 5 homes each for the DC and AC supplies. And then we will need the charging station capable of charging 20 lithium-ion batteries per day, and then we need about 40 batteries in total, so 20 in use and 20 in charging or in circulation. So as I indicated before, that we have approached suppliers for a budget estimate. So on the material side, we are looking at roughly 60 or 40% split between the third party and the participating household or the municipality, if the municipalities are interested. So among the 10 households, a third or 2/3 split between the DC and AC homes. So at stage 2, so we want to test the operational issues to see the players' different roles: the owner, the operator, the battery manufacturer, the mobile battery distribution, delivery, and the household. So player A is the charging station. So this party has to bear the initial investment to establish the charging station, to manage the battery charging, to monitor state of charge, state of health of batteries, to decide its own electricity price, to predict the user demand over time, or to become a trade of a secondary life or second-hand batteries. So it will need to create jobs for operators. For our particular case with the mine has already everything in this regard. So we can test with the existing system. So player B is the battery manufacturer. So that is to manufacture the required battery energy storage system according to technical specifications such as capacity, power interface, plug and play, safety features, to make sure production with local content, to recruit local technicians for assembly and quality assurance and associated training. So they will need to provide technical support for battery detection and testing. It will be able also to fix the problems and maintain the products, especially from the battery side. So the player C will be the battery delivery. So this party will distribute and deliver fully charged batteries from the charging station to the end users. It will help with the battery installation with the end users. It will collect and empty the batteries and return them to the charging station, or it will efficiently manage the user's bookings, reservation, and request. So when I say delivery and distribution, so it can be a physical distribution or delivery, but it can also be installation right at the residence. So then there's no actually physical delivery. So at phase 3, it will test the commercial feasibility after proving success from the pilot and operation. So it will look at the rolling out communities by adding more benefits when considering wheeling the power and the peer-to-peer energy trading. So it will also look at other opportunities such as support and a green transportation in view of the upcoming emerging electrical vehicles and buses. So assuming that everything works, we can do a very simple payback calculation. So for a DC home, the initial cost is 15,942, so which we got it from the supply. We do not at the moment have a tax incentive for individuals. So we do have that 12B for tax incentive for companies, but we don't have it for individuals. But I do not see that we should not introduce these incentives for individual salary earners, because I know that many other countries are doing exactly the same. So let's assume that this will happen, and then an individual can get 28% of tax rebate from his down payment to get his home ready for solar. Then the actual cost is actually 11,500. So assuming other technicalities, let's also assume that the battery electricity is priced at about 1 rand rather than 2 rand they are paying at the moment. Then we are looking at about 3.14 years to recover the money. So similarly for the AC home, so the simple payback we can calculate to be about 4 years. And for the third-party investor interested in investing, say, 100 megawatt IPP, which we have been spoken about in these 2 days. With 100 megawatt, you don't need a license from NERSA, and then we can optimistically scale it up. Or if you really want to bring it up to the scale of Mudupi again, you can look at the investment return of about 4.29 years. So when I use the term a third party, I certainly do not want to exclude Eskom. Eskom has all the licenses And Eskom needs only 42 billion in our calculation instead of 175 billion, or 75% less to get the same another Medupi, and a much cleaner and a much quicker, which we as customers are paying half of the electricity tariff. So I must admit that I'm not an economist, but fortunately we've got an economist from the University of Pretoria, nor a businessman, nor a lawyer, but we got the lawyer here also from UP, and rather a politician. But this is how an engineer would see the load shedding problem. So if you're looking for a solution, a quick solution to load shedding from me as an engineer, so that from my own system, from my own experiences, and especially from my wife's happiness, since we had our own system. So then my message to you is go solar really, go solar together. Thank you very much for your attention.